Welcome to DWBIADDA channel. Please subscribe for latest training videos.
Hello everyone. Welcome to this tutorial on multiple linear regression. Multiple linear regression is similar to simple linear regression. In simple linear regression, we had only one dependent and one independent variable, whereas in multiple linear regression, we will teach machine to predict the values of dependent variable from two or more independent variables. First, I have imported the libraries that would be required: matplot library for plotting the graphs and pandas for reading my dataset. I have imported my dataset using readCSV function of pandas, and then I have initialized my x and my y. Here, this is my dataset. My dataset consists of column values R&D spend, administration, marketing spend, and profit. We need to find out profit based on the amount spent on R&D, administration, and marketing. So basically, my multiple x variables would be R&D, administration, and marketing spend, and I would like to predict the profit from that. So I have read my x and y. I have initialized my x and y values with R&D spend, administration, and marketing with my x, and profit with my y. Then I will be splitting my data set into training set and test set. I have used the function called train_test_split function. This function basically splits your complete data set into fractions. Here I have given my test size equal to 1/5, which means my testing data will be 1/5 of my total data, and my training data will be 4/5 of my total data. The mathematical equation of multiple linear regression is y equals to b0 plus b1x1 plus b2x2 so on till bn xn, where y is my dependent variable, b1, b2, b3 are my constants, x1, x2 and rest of them are my independent variables. So basically this is my x1, x2, x3 and this is my y. We need to calculate b0, b1, b2 and so on, these values. Now we will see how Python's Scikit Learn library for machine learning can be used to implement the regression functions. So after splitting the data into training and testing sets, finally the time is to train our algorithm. For that, we need to import the linear regression class, and then we will be instantiating our regressor. Once that is done, we will call a fit function giving it the parameters as xtrain and ytrain, the training data set. Once the fitting is done, it will return you a best fit for the particular data, and then you can get all the intercept and the theta values. You can get the intercept from the arguments. If you call regressor the object dot intercept underscore, you will get b0 value. If you call regressor dot coefficient underscore, then you will get all the other coefficient values related to your x values. And at the end, I have tried predicting all my testing data set. We would call our predict function using the object regressor and then pass our testing data to it, which will give us all the predicted y values. And then we have tried comparing our actual values and our predicted values. So the intercept I got here is 42989. The theta values for x1, x2 and x3 is this. And then you can have a comparison between the actual and the predicted values.